Okay, now that you have completed your initial assessment of the billboard through a walk around inspection, the next thing that you want to do is take a very close look at the safety cable. The safety cable is going to essentially be your lifeline in the event of a fall to prevent you from being injured or possibly killed. Now, this picture has several things that are wrong with it, and I hope at the end of us talking about safety cables, you'll be able to recognize some of these a little bit easier. Safety cables are engineered to operate as a system, and there are some very specific things that have to be done rather than just throwing a cable up in the air. You can tell here that this is 3/8 inch wire rope cable with a thimble to keep it open around this 3/4 inch drop forged eye bolt that's double nutted on this end, and 3 Crosby clamps approximately 4 inches apart. These are roughly the width of an installer's hand as you go down, and this tail on the cable where it's been cut is actually a little bit short in this picture. Now then, you can see that it runs the full length of this board. You can see these areas that I was talking about where the clamps are applied, and you have the U-bolt over it with the actual clamp piece and the nuts on the bottom, which is considered the live side. And you'll note that this cable is pulling in a direct line on this eye bolt. It's been reported by the eye bolt manufacturers, if you pull on it from a sideways angle, you can reduce the strength capability of this eye bolt by right around 50%. So it's very critical to make sure that it pulls in a straight line like this. If it's not installed this way in this configuration, it could be hazardous to hook into if you were to have an impact loading on it during a fall. Now here's some specs on the cabling: 3/8 inch 7x19 galvanized steel aircraft cable, capable of withstanding 14,000 pounds of impact. Additionally, there should be some slack in this cable unless there is some other type of device installed, such as a thing called a Zorbit, that is a shock absorber essentially that unfurls if a load impact is put on it. However, in most cases you'll see where there is this type of deflection, as it's called, where you should have approximately 16 1/8 inch sag if you apply a 10-pound weight at the middle of a 48-foot span of this cable. Now, cabling requires securement, and one method of securement that's very popular due to the ease of installation and the cost associated with it is clamping. All of the safety cables used in the billboard industry have to be triple clamped, and if you're going to clamp them, they have to be clamped correctly. The top picture shows just what we were talking about, where the U-bolt is over the short, or what's called the dead end. There's no load put on this part of the cable. The live end, the long end that you would actually hook into, is where the saddle is actually applied, and then it is tightened down to the manufacturer's spec. If you do it incorrectly, such as staggering the clips, or you put the saddles on the wrong side, the cable may actually slide out of those in the event of a fall and cause you to hit the ground. Now here's a close-up. You can see the U-bolt and the saddle a little bit better, and the tightening nuts that secure everything. And a good way to remember which side goes where is this saddle goes on the live end. And the old installer's phrase of "you never saddle a dead horse" is what applies to this type of configuration whenever you're installing a safety cable. Now, there is another method of installation called swaging. And swaging is where you actually take a special tool and a special clamp, and you clamp it onto the cable to hold it in place rather than using the Crosby clamps. This has to be a rated method, and it has to be a method that is installed by someone who's been properly trained to swage a cable at the end. It's the definition of that is swaging refers to the process of using a tool or machine to crimp or apply force to a sleeve or a ferrule. And through this process, the sleeve becomes compressed around it and it clamps down and it hangs on to a portion of that cable. You also need to look for defects on the cable. Now, some of these you'll be able to see from the ground. Some you will have to look for once you're up there and hooking into it. Remember, you have to be hooked up 100% of the time when you leave the portable ladder and you ascend on a fixed ladder, or you land on a deck and you go to transition across the front of the board. You can see where there are broken strands in this lay of this cable. In addition to which, there's these kinks that have occurred where the cable has kind of been backspun and it's caused them to pop out. Corrosion is a very common problem in areas that have a corrosive environment, like near the coast, and severe wear is where the cable has been up there so long that the hook has slid back and forth to the point that it's started to flatten out the lay in the cable. And bird caging is where the cable has actually been kinked and twisted, which causes it to pop open in the middle. You also need to be aware of these devices of which I was telling you about earlier, the Zorbit, which has a connection on each end, and rather than having the slag built into it, there is a tensioning that's required to be on it. The Zorbits have had a recall on some of them, so if you encounter these on a board that you may not own or one that you acquire, you might want to contact the Zorbit company and ask them if the system that is up there is acceptable.